Namaste. Let us discuss one of the important concept in chemistry that is known as redox reaction. So in this video we are going to discuss about what are redox reaction and the definitions associated with the redox reaction like oxidation reduction and oxidizing and reducing agent. So let us begin with a journey to understand what is redox reaction. Now, redox is a combination of two words, oxidation and reduction. So, in the word redox, ORED is taken from reduction and OX is taken from oxidation. So, let us define redox reaction. So, the reaction in which oxidation and reduction takes place simultaneously, that means one after another, that means one substance undergoes oxidation, other substance undergoes reduction, that is known as redox reaction. So I have the reaction in which oxidation and reduction takes place simultaneously, that is known as redox reaction. Now let us discuss what do you mean by oxidation and what do you mean by reduction. So I have jotted down some definitions of oxidation and reduction which will be helpful to us in order to understand the redox reaction in detail. Now, first we try to define about oxidation. So, the very first definition, that is addition of oxygen to any substance. If we add oxygen or to any substance with which we react oxygen, so we say that substance is oxidized. So, addition of oxygen is taken as oxidation. So, let me have a simple example to understand this. So, I have magnesium. Okay, I have magnesium. Okay, so magnesium metal is reacted with oxygen, so it gives me corresponding magnesium oxide. So I say magnesium is getting oxidized. Then second definition, that is removal of hydrogen. So let me take one example to understand this. I have an H2S hydrogen sulfide when reacted with bromine. Okay, so it gives me 2HBr plus S. So from hydrogen sulfide, I have removed the hydrogen. So I say that hydrogen sulfide gets oxidized to sulfur. Hydrogen sulfide gets oxidized to sulfur. So there is a removal of hydrogen here. The next, addition of electronegative element. So let me take ferrous chloride, FeCl2, when reacts with chlorine, it gives me FeCl3. So 2FeCl2 gives me 2FeCl3. So in this particular case, chlorine is an electronegative element. So I have added chlorine to FeCl2 in order to get FeCl3. So it is considered as your oxidation. So let me move further toward another definition. Loss of electron. Any substance which loses electron. So I have sodium metal. When loses one electron, gets converted into sodium ion. So this is considered as loss of electron. We consider it as your oxidation. Increase in positive valency. I can have stannous chloride or Sn plus 2 ion, stannous ion, further loses electron, get converted into stannic ion. So stannous ion undergoes oxidation to give you stannic ion. So there is an increase in positive valency. Plus 2 gets converted into plus 4. So increase in positive valency is also called as an oxidation. Decrease in negative valency. I have Cl minus 1. Will lose one electron and gets converted into Cl0. So minus 1 getting converted into 0, that's considered as your decrease in negative valency. That's your oxidation. Decrease in negative valency, that's oxidation. So these are the few definitions of oxidation. Now let us focus on the definitions of reduction. Now, first is addition of hydrogen. So let me have chlorine reacts with hydrogen gas in order to give me hydrogen chloride. So I say that chlorine get reduced to chloride radical. So I have added hydrogen to the chlorine in order to give me HCl. Then removal of oxygen. I have zinc oxide when reacted with hydrogen, or I pass hydrogen gas over a heated zinc oxide, I'll get zinc plus water. So I say that zinc oxide gets reduced to zinc. So what is the hydrogen is there? It has removed oxygen from zinc oxide. So the removal of oxygen, I called it as a reduction. Then you have a removal of electronegative element. So let me have HgO, that is mercurous oxide. When I heat it, it gives me mercury metal and oxygen gas. So from this mercuric oxide, I removed the oxygen as an electronegative element. Okay, so I call it as a reduction. The gain of electron. So once again, I can take up an example here. Sulfur will gain 2 electron and gets converted into S minus 2. So there is a gain of electron. That's called as your reduction. Then I have an oxygen atom which has got 6 electron in its outermost shell, readily gains electron, gets converted into O minus 2. So there is an increase in negative valency, O0 getting converted into O minus 2. That's called as your reduction. Then I have Mn plus 5. When gains 3 electron, gets converted into Mn plus 2. So that's decrease in positive valency. We considered it as an reduction. Now, out of this many definitions, we try to see that the first definition, then that is addition of oxygen, removal of hydrogen, increase in positive valency, and loss of electron. These are of much significance. Here, the addition of hydrogen, removal of oxygen, gain of electron, and increase in negative valencies. This definition holds good over here in order to understand oxidation and reduction. Okay. Now, to understand oxidation and reduction on number line, so it's very imperative. Just if you can try to work out how I can understand oxidation reduction using a number line. So let me draw this. Let me draw a number line here. Okay. Here I have a 0. Here plus 1, plus 2, plus 3, and plus 4. Then here I am having minus 1, minus 2, minus 3, minus 4. So if I move from 0 to plus 1, plus 2, I say I am undergoing oxidation, increase in positive valency. And if I am moving from 0 to minus 1 to minus 2, I am saying that I am undergoing reduction. So this number line will help us to interpret if I am getting confused some way, to understand whether the substance is getting oxidized or reduced. Now, after gaining the understanding about oxidation and reduction, let us focus one more thing, that is your oxidizing agent, or what is called as oxidant, and what is reducing agent, that's a reductant. The oxidizing agent is that substance which itself undergoes reduction. The substance which itself undergoes reduction but will help in oxidation of some else substance, that's called as your oxidizing agent. So oxidizing agent is a substance which itself undergoes reduction but helps in oxidation, that is called as your oxidizing agent. And reducing agent is that substance which itself undergoes oxidation but helps in reduction, That is called as your reducing agent. That is called as your reducing agent. Now let us study few of the common oxidizing and reducing agents which are there in solid state, liquid state, or the gaseous state. Now let me have the oxidizing agents in solid state. I'm having manganese dioxide, that is MnO2, a black color solid. Then I have Pb3O4, that is trilead tetroxide, which is called as red lead. Okay, the sindoor, which we commonly call it as in, it's an orange red color solid we can have. Then potassium permanganate, KMnO4. Okay, it's an purple color solid we can have. Then I have K2Cr2O7, that is potassium dichromate. It's an orange solid. It's an orange solid we can have. Then I have bleaching powder. It's called as calcium oxychloride, CaOCl2, which is known as bleaching powder. Everyone knows this. It's a white color solid. And potassium nitrate, KNO3. Okay. Now these are the oxidizing agent which are present in solid state. MnO2, that's manganese dioxide, trilead tetroxide, potassium permanganate, potassium dichromate, calcium oxychloride, bleaching powder, and potassium nitrate. These are the oxidizing agent present in solid state. Then I have hydrogen peroxide, H2O2. It's a liquid. Then HNO3, both dilute as well as concentrated. They will act as an oxidizing agent. Dilute and concentrated HNO3, that's nitric acid, will act as an oxidizing agent. Then I have concentrated sulfuric acid. Concentrated sulfuric acid will act as an oxidizing agent, but it's in liquid state we have. Then in gaseous state I'm having oxygen gas itself. Then I have ozone, that's O3. Then sulfur dioxide gas and chlorine. Now, if you carefully look at the list of all oxidizing agent, if you carefully look at the list of all oxidizing agent which is listed above, one thing you must have been noticed. One thing you must have been noticed. What's that thing? Correct. You must have think of all the oxidizing agents have got oxygen common. All the oxidizing agents have got oxygen common. But if you carefully look at here, chlorine. But if you carefully look at chlorine, it's an oxidizing agent which do not contain an oxygen. It's an oxidizing agent but do not contain an oxygen. So please do remember this. Chlorine is an oxidizing agent which do not contain an oxygen. Rest all the oxidizing agents which have been listed above will have oxygen there, will have oxygen there. Now let us focus on reducing agent. Let us focus on reducing agent. So what are this reducing agent? Now reducing agent is a substance which itself undergoes oxidation but helps in reduction. That's already we discussed. Now what are the reducing agents which we have in solid state? Which are the reducing agents we have in solid state? So I have carbon, that's a reducing agent. Then we have metals. Now as we know, metals have greater tendency to lose electron. Metals have got greater tendency to lose electron. So they will act as an reducing agent because they undergo oxidation quickly. So metals we have. Then we have metal hydride. Okay. Then we have glucose. The formula glucose is C6H12O6 and stannous chloride, SnCl2. It's called as stannous chloride. Now these are the oxidizing agents which are present, reducing agents in solid state. These are the reducing agent present in solid state. Then in liquid state, I have hydrogen iodide, I have hydrogen bromide, I have hydrogen dihydrogen oxide, sorry, that's hydrogen peroxide, that's H2O2 we have. So hydroiodic acid, hydrobromic acid, and hydrogen peroxide. So that acts as your reducing agent. Then in the gaseous state, I have carbon monoxide, sulfur dioxide, hydrogen sulfide, and hydrogen gas itself. Hydrogen gas itself. So this will act as your reducing agent. This will act as your reducing agent. So this is about your. Now let us understand the redox reaction and oxidizing and reducing agent with some example. So I have a reaction here like H2S reacts with chlorine in order to give me HCl plus S. So to balance this, I'll have here 2 HCl. Now we need to find out which is undergoing oxidation and which is undergoing reduction. Now if I take here hydrogen sulfide to sulfur, hydrogen sulfide to sulfur. Now there is a removal of hydrogen, and chlorine to HCl. There is addition of hydrogen. So as well known fact, we have removal of hydrogen is known as oxidation, and addition of hydrogen is known as reduction. So I say here hydrogen sulfide is oxidized to sulfur and Cl2 is reduced to hydrogen chloride. And in this reaction, chlorine has undergone reduction. That's why chlorine will act as an oxidizing agent. So chlorine is acting as oxidizing agent. Chlorine is acting as oxidizing agent. Let me take another example to understand the reaction. One more reaction to understand here. Let me take copper oxide, CuO, reacts with NH3 in order to give me Cu, N2 and H2O. Now see, copper oxide to copper. What I observe, this is removal of oxygen and NH3 to N2. This is removal of H2. Now we know in earlier definitions a removal of hydrogen, and here I have another one, that is removal of oxygen. So we have studied in earlier definitions of your reduction and oxidation, removal of hydrogen we call it as an oxidation, and removal of oxygen I call it as an reduction. Removal of oxygen I call it as an reduction. So I say here copper oxide is reduced to metallic copper and ammonia is oxidized to nitrogen. Therefore, ammonia is acting as reducing agent. Ammonia is acting as reducing agent. Thank you for watching.